Hello everyone, this is Cavell, and today we will be going through the Algebra 1 Regents of New York. This is a 3-hour test, so it says you only have you can use a graphing calculator and a straight edge ruler must be available for you to use while taking this exam. So let's go ahead and start. Alright. So number 1 says Brian's hockey team is purchasing jerseys. The company charges $250 for a one-time setup fee and $23 for each printed jersey, which expression represents the total cost of X numbers of jerseys for the team, right? So obviously the $250 is going to be the constant, right? And $22 for each X. So yeah, so here you go. So it'd be oh, so it'd be 2 for 30 plus 23x, alright? Which is choice this choice 3. Alright, so that's for that one. Alright. Okay. Which table represents a function, right? So for a function, right, you need to have a graph that passes the vertical line test, which means if you have a function that looks like this, right, one x value cannot have two same outputs. Okay, so let me repeat that again. An input or an x value cannot have two different outputs. Okay, so let's see. So this is a function so far. Let's see. This one is no good, right? Why is that? Because if you were to plot these points, right, this -3, 0 and -3, 2, right, this would be -3, right? This, so you'd have one here, -3, 0, right? And then you have another one. So what does that mean? This is not a function, right? You can't have two outputs with the same input. So that's for choice 3, right? Which expression is equivalent to 2 times x squared minus 1 plus 3x times x minus 4? So if I look at the choices over here, they are pretty much simplifying everything, combining like terms. So let's do exactly that, right? So 2 times x squared minus 1 plus, oh, sorry about that, 3x times x minus 4, right? So let's distribute, right? You have 2x squared minus 2 plus distribute. 3x times x is 3x squared, right? 3x times 4 is minus 12x. Combine like terms, I get 5x squared. These are gone. Minus 12x. This is gone. Minus 2. So 5x squared minus 12x minus 2, which is choice 4. All right. Okay, now let's just do number 4. The value of x that satisfies the equation 4/3 equals x plus 10/15 is, okay, so we need to solve for x, right? So we have 4/3 is equal to x plus 10/15. Multiply both sides by 15. Okay. Okay, and then we get 60/3 on the left side, which is basically, this is basically 60/3, which is 20. 20 is equal to x plus 10, right? These cancel out. And then you have minus 10, minus 10, you have x is equal to 10. Okay, and we can check that, right? Because 4/3 is equal to 20, where x is equal to 10, then it's 20/15, right? And then if you divide by 5, you get 20/15 is basically 4/3. All right. So the answer to question number 4 is choice 3. Okay. Let's see, Josh graphed the function f of x equal to negative times 3x minus 1 squared plus 2. You then graph the function g of x is equal to negative 3 times x minus 1 squared minus 5 on the same corner plane. The vertex of g of x is. Okay. So if you think about the question we have here, all these graphs, right, they're already in vertex form, right? So in other words, these two graphs are pretty much the same parabola with different vertexes or vertices, right? So for the first one, right, remember, for any quadratic in vertex form, h comma k is your vertex, right? So with that in mind, right, the vertex of f of x becomes 1 comma 2. Okay, g of x's vertex is 1 negative 5. Okay, so if you look at the graphs, you have 1 negative 5, so negative 5 right here, 1 negative 5, and a 1 2. Okay, so the vertex of g of x is this one. So g of x, right, is 7 units below the vertex of f of x. Alright. So one thing I do want to say is that if you look at this equation right here, you have negative 3 times x minus 1 squared minus 5. A mistake people would make is that they would think that the vertex is 1 comma 5, but remember, it has to be the vertex has to be put into this form of x minus h squared plus k, right? So the k in here in this second one is minus 5, right? Because you would rewrite this equation as g of x is equal to negative 3 times x minus 1 squared plus negative 5. So that's why this vertex is negative 1, 5. Okay. Or sorry, 1 comma 5. I apologize for that. And then for the other one, f of x, it's still 1 comma 2. All right, that's pretty much it for this question. So so choice 5 is 7 units below the vertex of f of x. All right. Okay, a survey was given to 12th grade students of West High School to determine the location for the senior class trip. The results are shown in the table below, right? And it says to the nearest percent, what percent of the boys chose Niagara Falls, right? So what percent of the boys chose Niagara Falls, right? So percent of the boys, right? So that means we're strictly talking about the boys, right? We're comparing the amount of boys that went to Niagara Falls to the total. So we have 56 over 56 plus 74 plus 103, right? So 56 plus 74 is, I believe it's 130. 130 plus 103 is 233, right? So let's pull up a calculator here. 104, 103, right? 233, yep. So I have 56. So you have 0.24. So to the nearest percent, it's going to be 24%, okay? Is 24%. Okay. Let's see. What type of function is shown in the graph below? Okay, this is not too bad. It's pretty easy. Just erase this. Okay. What type of function is shown in below? This is definitely not linear. Linear, you'd have a straight line. Square root? No, square root looks something like this. right? Let's see, and this is definitely not absolute value because absolute value always has some kind of v-shaped, so this is definitely exponential. Okay, so answer for 7 is choice 2. Okay. Next one is the expression 16x squared minus 81 is equivalent to. So once you see this type of quadratic, right, you should think of difference of two perfect squares, right? Difference of two perfect squares, because 16x squared is a perfect square and 81 is a perfect square. So anytime you have a squared minus b squared, right, this simplifies to, or sorry, this factors to a plus b, right, and a minus b. So for 16x squared minus 81, this is basically square root of this part, which is just 4x plus 9, because 9 is square root of 81, right? So let me make that 9 a little bit better looking. There you go. 4x plus 9 and 4x minus 9, right? You can check this by foiling, okay? This is 16x squared minus 36x plus 36x, right? Minus 81. The middle stuff cancel out, and you just left with 16x squared minus 81. Alright, so the answer is 4x plus 9 and 4x minus 9. So 4x plus 9 and 4x minus 9. Alright, so the answer to this problem is choice 3. Right there. Alright. The owner of a landscaping business wants to know how much time on average his workers spend mowing one lawn, which is the most appropriate rate with which to calculate an answer to his question. So we want to see how much, the appropriate rate, right? So we want to see, how long does it take for a worker to mow the one lawn, right? Or the workers to mow the one lawn. So lawns per employee, no, that means the number of lawns is being divided by the number of employees. That doesn't really make sense, right? 3 employees per lawns, that doesn't really make sense, because we're talking about one lawn, right? So automatically you can see that these 3, right, are not really good. I think definitely the 4th one is the best. 4 hours per lawn, the amount of hours it takes. But let's see, which is the most appropriate rate with which to calculate and answer this question. How much time on average does the worker spend? Yeah, I would definitely say 4 hours per lawn. Yeah. So choices number 9 is choice number 4. Okay. Number 10, a ball is thrown into the air from the top of a building. The height h of t of the ball above the ground t seconds after it is thrown can be modeled by h of t is equal to negative 16t squared plus 64t plus 80. How many seconds after being thrown will the ball hit the ground? In other words, what we want to know when height, right, is equal to 0, right? Because when height is equal to 0, what does that mean? The ball is on the ground. So let's look. H of t is equal to 16t squared plus 64t plus 80, right? We want to know when the time of t when this is equal to 0. So we could divide by negative 16 all over. We get t squared, right? 64 divided by negative 16 is minus 4t. 80 divided by negative 16 is minus 5. Okay? So t squared minus 4t, 64 divided by negative 16 is 4, or sorry, negative 4t. 80 divided by negative 16 is negative 5. We equal this to 0 because we want to solve for t, right? Now we need to find two numbers such that it adds to -4 and multiplies to -5. So since we know that it's going to be a negative, or multiplies to a negative answer, right? What do we know? We know that it's going to have to be a positive and negative, right? So since it's going to add to a negative, we know the negative number is going to be bigger. So it's going to be t minus 5 times t plus 1. How do I know this? -5 plus 1 is -4. -5 times 1 is -5. So the two conditions are satisfied. So if we solve for t, right, we have t is equal to 5. And t is equal to -1. Okay? Because we do t minus 5 is equal to 0. T plus 1 is equal to 0. And then here we get t is equal to 5. T is equal to -1. Alright. So you're looking at me, you're like, Cavell, there's like two answers here. It's -1 and 5. That's not true. Since we're dealing with time, right? It has to be a positive number. In other words, we have to reject this answer because it's negative. You can't have negative seconds, right? So the answer is t is equal to 5. So 5 seconds after the ball is thrown, right, it'll hit the ground, right? So the answer is 1, 5. Okay. All right. Which equation is equivalent to y is equal to x squared plus 24x minus 18, right? So here, what they did is they basically completed a square, right? So let's do exactly that. Oh, so completing the square, x squared plus 24x minus 18. We set this equal to 0, okay? We add 18 to both sides, so we get plus 18, right? So to complete the square, we need a half of b, right, which is 12, right? 12 squared is equal to 144. Okay, and then remember we have to add 144 to both sides, because whatever you add to one side, which is the 144, you have to do to the other as well. So remember this part, right, simplifies to x plus 12 squared is equal to 18 plus 144. So this is 162. X plus 12 squared minus 162 is equal to 0. So this is our final answer. Now if you look at, or this is equal to y, sorry. This is equal to y. There you go. It's a lot easier. All right, x plus 12 squared minus 162. That's choice number 1. All right. So for 11, it's choice number 1. All right. Next problem. When x times x minus 5 times 2x plus 3 is expressed as a polynomial in standard form, which statement about the resulting polynomial is true? Okay. As a polynomial in standard form. So that means we need to, distribute and, expand this whole expression. So let's expand this middle part first, and then we can just distribute the x afterwards, alright? Actually, we could just do it all at once. So we have x squared minus 5x times 2x plus 3. Remember, I distributed x to both sides, or to both terms. Let's do FOIL first, right? So we have 2x cubed outer plus 3x squared inner minus 10x squared, and last, which is minus 15x. Okay, combine like terms. We have 2x squared, this is gone. 3 minus 10 is negative 7x squared minus 15x. Okay, this is equal to 0. Okay, or this is just equal to the same expression. So the constant term is 2. That's incorrect because there is no constant term, right? It's actually plus 0. The leading coefficient is 2. That's correct. The degree is 2. That's wrong because the highest degree here is 3. The number of terms is 2. That's also incorrect. So it's going to be choice number 2. The leading coefficient is 2. Okay. So choice number 2 is the answer for number 12. All right. The population of a city can be modeled by P of t is equal to 3,810 times 1.0005 to the 7t power, where P of t is the population of t years, which function is approximately equivalent to P of t. So if you look at it closely, right, we have P of t is equal to 3,810 to the 1.0005 to the 7t. One thing you can see is that you can actually simplify this stuff right here. You cannot distribute the 3,810 into here because this is being raised to an exponent. So what you can do is use the power to power rule and realize that 1.0005 to the 7t power is basically 1.005 to the 7 power to the t. Okay, let's call the power to power rule. Let me make this 5 or 0 a little bit better looking. So this is basically the same thing as this stuff right here. Same. Okay. So now let's do that. So we have to. So if you have what you call it, a graphing calculator, it'll be a lot easier. But you don't really need to. The 7th power, right? So we have 1.0035, right? So this is 3810 times 1.0035 to the t. Okay. So these are obviously all wrong. This is wrong. So the answer to number 13 is 2. All right. Let's see. Okay. The functions f of x and g of x are graphed on the set of axes below, for which value of f of x is f of x not equal to g of x, right? So if we label these points, right, they intersect at 1, 2, 3. This is -3, comma 1. Sorry, no, this is 1, 2. This is -2. Sorry. -2, 1, 2, 3, 4, 5. This is -2, 5. Okay. -1, 1, 2, 3, 4. Intersect there, and then you also intersect at 1, comma 1. So the question is asking for which value of x is f of x not equal to g of x. In other words, when do they not intersect, right? So they intersect at -1, that's no good. They intersect at -2, that's no good, right? And let's see, so the two choices we have is 2, x equal 2, and x equal 3. So at x equals 2, right? Alright, sorry, this is supposed to be 2, comma 1. I'm sorry about that. So they intersect at 2, 1, -2, 5, -1, 4, right? So only time they don't intersect is when x is equal to 3. Where is x equal to 3? So this is 1, 2, 3. At x equals 3, there's nothing intersecting with g of x. Alright. So the answer to problem number 14 is choice 3, which is also 3. Here we have a box and whisker plot. It says where's the range of the box plot shown below. So the highest value is 8, or the maximum is 8, minimum is 1. Range is equal to max minus min. So we have 8 minus 1, which is equal to 7. So the range is 7, right? 15 is choice 1. Okay. Which expression is not equivalent to 2x squared plus 10x plus 12, right? So let's see exactly that, right? So what we can do is factor out 2x or sorry, 2 from 2x squared plus 10x plus 12. We got 2x squared, 2 times x squared plus 5x plus 6, right? This is going to be x times, x plus 3 and x plus 2, okay? So these are the two forms that it can be, right? So 2x plus 4, okay, times 3. So number 1 is good, right? Because if you distribute the 2 to each of these, so you can either have 2x plus 6 times x plus 2, or 2x plus 4 times x plus 3. So either or is fine. So let's see which one doesn't match. 2x plus 4 times x plus 3. This is good. Number 1 is equivalent to the expression. 2x plus 6 times x plus 2. 2x plus 6 times x plus 2. Number 2 is good. Number 3, 2x plus 3. We don't have a 2x plus 3 here. So choice number 3 is not equivalent to this, right? And we can see that, right? Because if we were to distribute this, 2x plus 3 times x plus 4, right? We get 2x cubed plus 8x plus 3x plus 12. That's 2x cubed plus 11x plus 12. This is not the same as the original, which is 2x squared plus 10x. Okay. Oh, sorry, I distributed it incorrectly. This should be a 2, by the way. So it should be 2x squared plus 11x plus 12. So it's not correct. All right. So for 16, it's choice number 3. 17, the quadratic functions r and x and q and x are given below. The function with the smallest minimum value is... Okay. So if we look at this for so let's see here. Okay. So r of x for the minimum, it's -2 comma -16, and the minimum is, so we have to do x is equal to -b over 2a, right? B is equal to 2 for q of x, right? A is equal to 1, so x is equal to -2 over 2. X is equal to -1. So they both, so this one's minimum is at x equals -1. So we have x squared, so -1 squared plus times 2 minus 8. We have 1 minus 2 minus 8, right? So 1 minus 2 is -1. Minus 8 is -9. So -1, -9 is the minimum for q of x. The minimum for r of x is -2, -16. So the function of the smallest minimum value is r of x with value of -16. Okay, so choice 2. A child's playing outside. The graph below shows the child's distance d of t in yards from home over a period of time t in seconds. All right. So as you can see, as time goes by, the child is getting closer and closer, right? Between 2 and 3, they're basically walking around, looking farther, and come back to it. So here they are going away, right? And from 4 to 6, they are basically the same amount of distance. So which interval represents the child constantly moving closer to home, right? So moving closer is this, 10 to 4. So it's from 0 to 2, right? So the answer is choice 1. All right. Here's an arithmetic sequence. It says a of 1 is equal to 6, and a of n is equal to 3 plus 2 times an minus 1 squared, then a2 is equal to, alright? So a of 2 is equal to 3 plus 2 is a to the 2 minus 1 squared, right? So a2 is equal to plus 2. So a1 is basically 6 squared. So 8 is 3 plus 2 times 36, because 6 squared is 36. 3 plus 72, says, so a2 is equal to 75. So that's a2. Alright. Choice number 1. Alright. So answer to 19 is choice number 1. Okay. The length of a rectangular patio is 7 feet more than its width w. The area of a patio, a of w, can be represented by the function. Alright, so the length of a rectangular patio, right, is 7 more than its width. So this is w, right? And here, 7 plus w is it's gonna be the length. The area can be a of w, can be represented by the function. So we need to do length times width, right, for area of a rectangle, right? So we have 7w plus w squared. Alright, so 7w plus w squared. So 2. The answer to 20 is choice number 2. A of w is equal to w squared plus 7w. Okay, this is choice 2. A dolphin jumps out of the water. A dolphin jumps out of the water and then back into water. His jump could be graphed on a set of axes where x represents time and y represents above or below sea level. The domain for this graph is best represented using a set of, x represents time, so domain corresponds to input, which is the x, which is the time, right? So if you think about time, right, can time be at 0? Yes, that's definitely possible, right? Yeah, but could it be integers? No, I cannot have negative time, right? Integers include negative numbers. Is it positive integers? That's definitely possible. Real numbers, definitely not. Positive real numbers, I would definitely say it's positive real numbers. Okay, so 4. Okay, because represents time, you can have decimals of times, you know, half an hour or whatever, 30 minutes, 0.0007 minutes, etc. So answer to choice 21 is 4. Positive real numbers. Okay. Here we go. Number 22. Which system of linear equation has the same solution as the one shown below? Okay. Alright. So let's just solve for this. So we have x plus y is equal to 5. So we can do 5 is equal to, or sorry, x is equal to 5 minus y. So 5 minus y minus 4. 10. 5 minus 5y is equal to negative 10. Negative 5 minus 5. Get negative 5. Y is equal to negative 10 minus 5 is negative 15. Negative 5 divided by negative 5. Y is equal to 3. Okay. And x is equal to 5 minus 3, so x is equal to 2. So these are the two equations we have. All right. All right. Okay, so those are the two solutions. X equals 2, this is good. Y is equal to 3, so 3 plus 2, so 1. 1 is correct, right? This one would be incorrect, because if y is 3, this is automatically not 3, negative 5. Negative 5 times 3 is negative 15. This one, negative 3 times 2 would be negative 6. Negative 5 times 3 is negative 15, so choice number 1 would be would be the right answer. Alright, so choice number 1 for number 22. Which interval represents the range of the function? Okay, so we need to find the maximum or minimum and see if it's a minimum or maximum. So since this is a concave up quadratic, we're gonna have a minimum, right? So let's find out what that is. X is equal to negative b, so negative 2 over 2 times 2. X is equal to 2 over 4. X equal to 1/2, right? So automatically I know 2 and 4 are incorrect, right? And remember, since we're talking about range, right, we are including 0.5 to infinity, right? So remember, you have to include the minimum, right? So answer is choice number 3. Alright, let's do number 24. It says, what is a common ratio of the geometric sequence whose first term is 5 and third term is 245? So if you remember, geometric sequence, right, in its explicit form is an is equal to a1, which is our first term, multiplied by r to the n minus 1, where r is the common ratio and n is the term. So we know that a3, right, is equal to a3 is equal to a1, right, which is 5 times r. N is equal to 3 because we're talking about the third term here, so we have 3 minus 1, or just r squared, right, because 3 minus 1 is just 2. Now if we look further, we substitute 245 into a3, so we get 245, right, is equal to 5 times r squared, right? Now to find out r, divide by 5. Divide by 5. 5 goes into 240 times. 5 goes into 45 9 times. So that means 40 plus 9. 49 is equal to r squared. Therefore, r is equal to 7 or negative 7. But since we're dealing with geometric sequence, it should be 7, which is choice number 1. All right, that's number 24. So choice number 1 would be the correct answer, which is 7. And actually, sorry, we can actually check that, because if we write out the sequence, if we multiply by 7, we get 35, right? 35 times 7, well, let's see what that is. So 3 times 7 is 21. So 30 times 70 is 210, right? 7 times 5 is 35, so 210 plus 35 is 245, right? So that means our answer is actually correct. Okay, remember this is n equals 1, n equals 2, n is equal to 3. All right, so that's for number 24, choice number 1. All right, let's go into these, I guess, short answer problems. All right. So it says, answer all 8 questions in this part. Each correct answer will receive 2 credits. Clearly indicate the necessary steps. Blah, blah, blah. Utilize an information proficient question to determine the answer. Note that diagrams are not necessarily drawn on scale. Alright, so let's show. So 25, it says if g of x is equal to negative 4x squared minus 3x plus 2, determine g of negative 2. So remember, g of negative 2 means what is g when x is equal to negative 2. So our function is negative 4x is equal to, or negative, g of x is equal to negative 4x squared minus 3x plus 2. So if x is negative 2, right? Let's rewrite this, right? This becomes g negative 2 is equal to, we have negative 4 times negative 2 squared minus 3 times negative 2 plus 2, right? So remember, anytime an exponent is to the even exponent, right, it's going to be positive. So we have negative 4. Negative 2 times negative 2 is 4, positive 4. So 4 times negative 4 is negative 16. Minus 3 times negative 2, that's going to be negative times negative, which is going to be positive, plus 6. And then plus 2, okay? So this is equal to negative 16 plus 6 is negative 10, right? Negative 10 plus 2 is negative 8. And this is all equal to, this is all equal to g of negative 2. So g of negative 2 is equal to negative 8. All right, that's for 25. Scroll down here. Okay, let's delete that. 26, the student is in the process of solving an equation. The original equation and the first step are shown below. All right. So it says original 3a plus 6 is equal to 2 minus 5a plus 7. 3a plus 6 is equal to 2 plus 7 minus 5a, and it asks, which property did the student use for the first step? Explain why this property is correct. So if we look at this part here, 3a plus 6, 3a plus 6 on the left hand side, still the same. Here, you can see that they're moving the 7 to this side, right? So what they used is something called the associative property, right? Actually, would it be associative? No, actually. It'd be commutative property of addition. Okay. Well, so what does that mean? That means 2 plus 3 is equal to 3 plus 2, right? You have commutative property of addition and commutative property of multiplication, right? Basically, it tells us that order does not matter. So which property did the student use for the first step? They used commutative property of addition, right? Explain why this property is correct. It's because 2 minus 5a plus 7 becomes 9 minus 5a, right? And 9 minus 5a, and this is still equal to 2 plus 7 minus 5a, all right? In other words, if I move the order of these addition properties where they're both positive, it's not going to matter, right? The answer is still 9, or when you add them together, you still get 9. So that's for number 26. Okay. Alright, 27. On the set of axes on the next page, graph the line whose equation is 2y is equal to negative 3x minus negative 2. Okay. Let me just copy this. Okay. Okay, so what are we graphing? We are graphing 2y is equal to negative 3x minus 2. Let's expand this. All right. So if we have a graph, right, and we want a graph, right, it's the best thing we can do is make this into a y is equal to format, right? And we are working with a linear equation, right, because x is 2 degree 1. So let's divide by 2 to both sides, right? So now we have negative 3x over 2 minus 2 over 2, which basically simplifies to negative 3x over 2 minus 1, right? So let's plug in some easy coordinates. Let's do x is equal to 0, y is equal to negative 1, okay? Another coordinate I'm going to do is x is equal to 2, right? The reason why I'm doing that is because I know the 2's are going to cancel out. And remember, to plot any line, right, you only need 2 points. You don't need 3, you don't need 4, you don't need 5, you only need 2. That is all you need, right? 2 points make a line. So, at x equals 2, right, we have negative 3 minus 1, which is equal to negative 4. Okay, we can see that. So let's plot these lines. So 0, negative 1. So let's do another color. Let's do 0, negative 1. Oh no. This is 0, negative 1. So this is 0, negative 1. 0, negative 1, and then we have 2, comma, negative 4. So this is 2, negative 4 is 1, 2, 3, 4. Okay. And now we should draw a line. Okay, so that's pretty much our line there. Okay, include arrows. All right, so remember this is 2 comma negative 4, and this is 0 comma negative 1. All right, and if you really want, you can check this with a Desmos just to show you guys. Oh, graphing calculator. Okay, so remember we have y is equal to negative 3x minus 2 all divided by 2. Okay, so here's our first point, 0, negative 1. And our next point was, let's do x equals 2. And this is our second point. So the reason I did x equals 2 is so I can see the 2 points that I'm talking about. 2, negative 4, and 0, comma, negative 1, right? So those are for the 2, okay? Alright, so now, let me fix this. Alright, this is not what I'm talking about. Alright, so we just did that. Oh no, I didn't know there's another part. Okay. The linear equation contains a point 2 comma k. State the value of k. Okay. So what does that mean? At, what was our initial function? So y is equal to negative 3x minus 2 all over 2, if you guys remember. So now they're saying there's going to be a point, right? 2 comma k, right? So that means x equals 2, y is equal to k. We want to find out what k is. So let's plug in x equals 2 into this equation, or this equation. So negative 3 times 2 minus 2 all over 2, right? this is what we have is equal to y, right? Negative 3 times 2 is negative 6. Negative 6 minus 2 is basically plus negative all over 2. So we have negative 8 over 2, which is equal to negative 4. So we have 2 comma negative 4. And if you look at the graph before, we can actually see that. We actually found this coordinate actually before, if you remember, right? Because I used the coordinate x equals 2 to make things a little bit easier, right? So k is equal to 4. All right, that's for number 27. Okay, number 28. The formula A is equal to VF. V, is that VR? Initial velocity, so it is V sub I over T. Solve the formula for the final velocity V of F in terms of initial velocity, V sub I, acceleration A, and time T. So basically, we want to solve for V of F. What does it mean when we're going to solve for V of F? It means at the end of the question, it should get something that looks like this. V sub F is equal to some blah, 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 right? So let's solve for it. I multiply by T over 1. T over 1, right? I get T times A is V sub F minus V I, right? And remember, I want to solve for V sub F, so let's add VI to both sides. So remember, this is plus, not T. So I get V of F, V sub F is equal to V. So this is a subscript, so let's write it a little bit smaller. Plus AT. So V I plus T A. Okay. So this is our answer right here. All right. So V sub F is equal to V sub I plus T A, or A times T, either or. All right, number 29. It says solve 3 over 5x plus 1/3 is less than 4 over 5x. 4 over 5 minus 1/3 for x. All right. So let's do that. Let's write this down first. X minus 1/3. So the first thing I'm going to do is multiply everything by 15. The reason I'm doing that is because I can see that all the denominators are 5 and 3s, and when we're dealing with fraction, you want to find common denominator and possibly get it out of fraction form. So if I multiply everything by 15, right? So 15 over 1, right? 15 over 1, right? So let's look at this. So 15 times 3, right? I could do 15 times 3, or I could see that 15 divided by 5 is 3, so I get 9x over 15 plus 15. Sorry. Yes, actually, hold on. So I should get 45x over 5 actually. So let's just watch what I'm doing. 15 over 3, 60x over 5 minus 15 over 3. And you can see that all these simplify. So 45 divided by 5 is 9x plus 5 is less than 12x minus 5. See, now this thing, right, is basically the same as this initial thing. I just multiply by 5 so I don't have to work with fractions, right? So let's solve for it. Let's add 5 to each side. Plus 5, I get 9x plus 10 is less than 12x. Oh, excuse me. And then you'd subtract 9x. And then you get 10 as less than 3x, right? Divide by 3, divide by 3. So 3 and 1/3 is less than x, or in other words, x is greater than 3 and 1/3. So we can either just leave this as is, or what you should always do is check your answers. So x is greater than 3 and 1/3, right? Well, let's check that, right? So if x is 0, let's check 3 and 1/3, right? So if this is 3 and 1/3, technically, right, I should have them equal to each other, right? So let's put this back into improper, actually. 10 over 3, right? So imagine if it was 10 over 3. So I get 3 over 5 times 10 over 3 plus 1/3. This should be less than 4 over 5 times 10 over 3 minus 1/3, right? 3's cancel out. This becomes a 2, so I get 2 and 1/3 is less than, this becomes a 2, right? You have 8 over 3 minus 1 over 3. I get 2 and 1/3 is less than 7 over 3. Okay, so we see that at 10 over 3, answers are equal, right? So now let's try a bigger number, right? So we're on a good way to checking right now. So let's check another number. Let's check 10, right? So if I did x is equal to 10, right, I get 3 over 5 times 10 over 1 plus 1/3 should be less than 4 over 5 times 10 over 1 minus 1/3, right? This becomes 2. I get 6 plus 1/3, or 6 and 1/3. This should be less than, this is 2, so I have 8 minus 1/3, which is 7 and 2/3. Obviously, we can see that we are correct because 6 and 1/3 is less than 7 and 2/3. Alright, so now let's check the other case since we have a little bit of time. Let's check for x equals 0. Alright. If x is equal to 0, we have 3 over 5 times 0 plus 1/3 less than 4 over 3 times 0 over 1 minus 1/3, right? So we have 1/3 is less than 1/3, right? And wait, what did we go wrong here? It's 1/3. That is weird. 0, 0. So yeah. Oh, sorry. So yeah, so when we plug in x equals 0, this is obviously not true because x has to be greater than 10 over 3. Right? So this is not true. Not true. Not true. Because 1/3 is not less than negative 1/3. It's actually greater than 1/3. Right? Greater than negative 1/3. So we just did it. We just checked our answer here. Right? Hopefully that wasn't too confusing. All right. And then let's see here. Number 30 says, is a product of two irrational numbers always irrational? Justify your answer. So whenever you do something like this where you're trying to show something, think of a case that may not be true, right? So think of two irrational numbers that multiply together and is not irrational. Is there such a case? Of course, right? So let's look at the numbers. Oh, hold on. square root of 2, right? If I multiply it with square root of 2, what do I get? I get 2. Square root of 2, right? If we look at the calculator, 2 to the is some weird, long, irrational answer, right? But see, when we have to square root of 2 times square root of 2, we get 2. So the answer is no. Because square root of 2 times square root of 2 is equal to 2, which is an example where the two products, or sorry, where the product of two irrational numbers is not irrational. Sorry if this is not too neat, but it should be legible. So, to generalize, in conclusion, is the product of two irrational numbers always irrational? No, right? And we provide an example. Square root of 2 times square root of 2 is 2, right? So the product of two irrational numbers is not always going to be irrational, right? That's for number 30. All right. Number 31. Solve for 6x squared minus 42 is equal to 0 for the exact values of x. So one good thing about this quadratic is that you can see that you don't have a b term, right? Usually for quadratics you have ax squared plus bx plus c is equal to 0, right? So there's no bx term, right? You don't have to worry about factoring, and you don't have to worry about the quadratic formula. Why? Because you can simply solve this, you can simply isolate x, right? So here's what you can do, right? So you have 6x squared minus 42 is equal to 0, right? So what you can do is add 42 to both sides. So you get 6x squared is equal to 42, right? Divide by 6, I get x squared is equal to 7. Square root both sides, so I get x is equal to plus or minus square root of 7, right? So this plus or minus 7 part is very important because with any quadratic, you have two roots, right? They're either both imaginary, right? Or both real, right? But either or, you're gonna have a negative version of it and a positive version of it, right? So my answer is x is equal to plus or minus 7, or you can just say x is equal to square root of 7, x is equal to negative square root of 7, right? And if you really want, you can actually use a quadratic formula. I do not recommend it because it's going to be a lot of steps, but in this case, a is equal to 6, b is equal to 0, since there is no b term, z is equal to minus 42. So we have x is equal to negative b, or negative 0, plus or minus b squared, which is 0, minus 4 a c, all over 2 times 6, right? We have x is equal to, oh sorry, this will be plus or minus. Plus or minus, right? 4 times 6 is 24. 24 times 42, what is that? 1008. Yeah, this is looking already insane, right? Okay. X is equal to plus or minus 1008. We could divide by 4, right? Because I can half 1008 2 times, therefore it's divisible by 4. What else? Oh, we can also do times 9, right? Square root of 9, because why? If you add the digits, the sum of the digits, right? If that sum is divisible by 9, the whole number is divisible by 9. So I know square root of 9, right? Or 9 times something gives me 1008. 9 times 100 is 900, right? I have 108 left. 9 goes into this 12 times. So that means this is 112. Okay. And then we could probably simplify this a little bit more. Yes. 112 can be a product of square root of 4. And let's see, if I half it, I get 56. Half it again, I get 28. Right? And then if you look at here, this could be broken down into radical 7, radical 4, right? So I've basically simplified this to radical 4, radical 4, radical 7, right? So remember, all of this is square root of 112. This is all over 12. Let me move the previous work over to the side here. X is equal to plus or minus, so you have 3 times 2 times 2 square root of 7 all over 12. 3 times 2 is 6, 6 times 2 is 12, so 12 over 12 becomes 1. So you get x is equal to plus or minus 7. Basically the same answer we got here. Alright, so obviously I do not recommend using the quadratic formula for this quadratic because it's just a lot of work, and you want to work smart. You want to work smart, you know? You got to be efficient, especially with a time test. I mean, gave me up 3 hours, so it's not that bad, but you know, when things hit the fan and it gets a little bit hairy and you know you don't remember how to do any of this, then you can use a quadratic, right? It's foolproof, but it's quite messy, right? So that is for no, that was for number 31. And now I have graphing function. All right, so let's delete this. So I've graphed the function. Okay, let me copy the set of axes. Okay, all right. So we're graphing the function here. We have h of x is a piecewise function, right? So when x is less than 0, right, meaning left of the y-axis, right, we have 2x minus 3, okay? And then from x squared, or sorry, when x is between 0 and 5, right, we have x squared minus 4x minus 5. So let's make a table, right? So let's just do x is negative x and y, right? So when x is negative 1, which is less than 0, right, I have 2 times negative 1 minus 3, right? H of x, right? This becomes 2 times negative 1 is negative 2 minus 3, right? Negative 2 minus 3, it's basically negative 5, right? Oh, well, let's do one more corner. Let's do 0, okay? At 0, right, we have negative 3, right? But this does not count because x has to be less than 0, right? But that's fine. There's no worries. We could put a hole in it. So in other words, this is going to be an open circle because it doesn't equal to this, right? Let's see, h of x from 0 to 5. So at 0, right? So remember, this is for 2x minus 3, right? So this is for x squared minus 4x minus 5. So when x is 0, right, you've got, let me delete this. You've got 0 squared minus 4 times 0 minus 5, right? So this is 0, this is 0, you have minus 5. So remember, these coordinates so far are -1, -5. This is going to be 0, 0, or sorry, 0, -3. Remember, this is going to be an open circle, right? This is going to be a closed circle, okay? This is 0, -5. Closed circle, right? Let's do a few more coordinates. We could do up to 5, honestly. So when x equal to 1, right, we have 1 squared minus 4 minus 5, right? So 1 minus 4 is -3. -3 minus 5, right, is -8. So I have 1, -8. Close circle. 2, we have 4 minus 8 minus 5, right? 4 minus 8 is -4, right? -4 minus 5 is -9. Next one is 3 squared minus 12 minus 5, right? So we have 9 minus 12 is -3. -3 minus 5 is -8. So this is, remember, this is a quadratic, so it's symmetrical about the vertex. So this can be -5. And I can show you that because 4 squared is 16. 16 minus 16 is 0, and a minus 5 is just -5. So, and for x is equal to 5, we have 25 minus 20 minus 5. So 25 minus 20 is 5. 5 minus 5 is 0. So these are the coordinates. 3, -8. 4, -5. And the last one is 5, 0. Alright, so all these represents closed circles. Only open circle is this one, right? So let's graph this. So let's do a different color. Okay, so let's do the first one. -1, -5, -1, right? 1, 2, 3, 4, 5, -1, -5, right? And then we have 0, -3, right? So remember, this is going to be open circle, right? 0, -3, 1, 2, 3. 0, -3, okay? And then remember, this one is where it matters, because this is actually where the point begins, or the graph begins for x equals 0. So we have 0, comma, -5, right? So let's make it a little bit thicker. 0, comma, -5, this is -3, 4, 5. Okay, 1, -8, so this is 1. This is 5, 6, 7, 8. 1, -8. Right? And then 1, -8. 2, -9. This is 2. This is -9. Right? 3, -8. Just right here. 3, -8. And then 4 is -5. Back here. 4 is -5. And then 5, comma, 0, which is right here. Okay. So let's draw some lines here. So here, looks like this. Oh, this is too thick. So remember, since it says x is less than 0, right? That means this goes on forever, right? Now, this is the part where it gets a little bit crazy because x is between 0 and 5 inclusive, meaning if you connect all, oh, that's no good. Here. Okay. So let's graph this. Alright, I don't know how to do this actually with the line thing, but this is what it looks like. Okay, so if you can see, right? Let me show you. So when x is less than 0, it's a line, right? It's going on to infinity, right? Because it's just as x is less than 0. But now when it's the quadratic part of the piecewise function, you stop right here, right? Because this is where x is equal to 5, right? 1, 2, 3, 4, 5. Okay, so this is h of x. Okay, so let me show you guys what I mean. This is x squared minus 4x minus 5 part. All right, so that's for number 32. Okay, let's see what the next set or next question is. All right, it says on the set of axes on the next page, graph the following system of inequalities. Okay. All right, so let's do that. So we have, here you go, 2x minus 2x plus y. Let's have another set of graph. So here you go, right? So let's do exactly that. So 2x plus y is greater than or equal to 8, right? We can solve for y by subtracting 2x. So we have y is greater than or equal to 8 minus 2x, right? Let me make this sign better. 8 minus 2x, right? The other line we have is y minus 5 is less than 3x, right? So for this one, I can add 5 to both sides. And I get y is less than 3x plus 5. So these are the two graphs I'm looking at, right? So just to generalize what I've done so far is I look at these two equations, right? And I've converted into a y equals format, right? So let's look at that. So let's do the first one. So let's delete the rest of this. Okay, this goes over here. This goes over here. Okay. So y is less than 3x plus 5. So let's just plot the line first. 3x plus 5. So let's see. So our first point, let's just do the intercept, which is when x is equal to 0, you get 5. So 0, 1, 2, 3, 4, 5. Right? And then when x is equal to 1, right? You get 3 plus 5, which is 8. So 1, 8, 6, 7, 8. Okay. And then, is there any way I can do a dotted line? Okay, so I can't really do a dotted line, but this will have to do. So I'm just doing a dotted line effect. Okay. Good enough. Okay. Oh, it's too thick. Okay. So y is less than this, right? So what does that mean? So for any coordinate, I want y to be below this. So it's going to be all of this here. So it's going to be all of this here. Okay? All of this, right? But so let's not do that yet. This is y is less than 3x plus 5, right? So the next one we have is y is greater than or equal to 8 minus 2x, right? So let's plot this guy first, or second. So at x equals 0, I have 8. Right, so 1, 2, 3, 4, 5, 6, 7, 8. And when x is equal to 1, right, I have 8 minus 2, which is just going to be 6. So 1 is 6. So 1 comma 6. So 1, x equals 1, 1, 2, 3, 4, 5, 6. Okay, so let's draw another line. Oh. Okay. Right, so y is greater than or equal to this, right? So remember the portion of the map or portion of the graph that was shaded in for this one. Okay, it was like all over here. And then for this one, since it's greater, it's going to be all over here. So the places that they overlap is right here. Okay. So this is the solution set. Okay. So how do I know if this is true? Let's pick a coordinate, right? Let's do a coordinate like 2, 3, 4, 5, 6, 2, comma 6. All right, at 2, comma 6, let's see. Is 6 less than 2 times 3 or plus 5? Yes, because 6 plus 5 is greater than 6. 11 is greater than 6, right? Let's check for this one. Y is greater than or equal to 6 is greater than or equal to 8 minus 2 times 2. 8 minus 4 is, right, so I have 6 is greater than or equal to 4, which is obviously true. Okay, so that's for the graphing part. So we graphed it, determine if the point 1 comma 8 is in the solution set. So let's see, 1 comma 8, 0, 1, 2, 3, 4, 5, 6, 7, 8. Is it? Well, let's see. Since it's on the dotted line, it's technically not, because it has to be within this border, right? I mean, anything on this line is good, right? But as soon as you hit this like dash line, there's no good. Okay, so let's try that right now. Let's actually see it for ourselves. Here you go. Oh. Okay, let's check for it out. So the solution said 1 comma 8, right? Let's see, y, so 8 is less than 3 times 1 plus 5. Is 8 less than 3 plus 5? No, it is not correct. 8 is not less than 8. It is equal to 8. So no, this is no bueno, right? No good. Let's try for the other one. Y is greater than or equal to 8 minus 2x. So we have 8 greater than or equal to 8 minus 2 times 1. 8 is greater than or equal to 8 minus 2. 8 is greater than or equal to 6. This is good, but remember, this is a system of inequalities, right? So I gotta satisfy both of them. All right. Satisfy both of them. Yep, that's it. Okay, so that's for that. It's both good. And then we can definitely check our answers. Let me show you Desmos again. Graphing. No, Desmos graphing. Alright, that's no good. What were the initial equations? So we had 2x plus y is to 8, right? Y minus 5 is less than 3x, right? So if you look at this graph compared to the one we drew, oh, where'd it go? Here you go. Right? You can see that the space that I filled out with the squiggly stuff is our answer. And remember, like I said, on this dashed line is not part of our solution set, right? This is where the dashed line is, just like I have over here while I try to replicate it. And but anything on this line over here is good. Anything on this line is perfect, okay? So that's for, I could leave that up for later, perhaps. That's for 33, all right? Okay. Let's see what this is about. On the day Alexander was born, his father invested $5,000 in an account with a 1.2 annual growth rate. Write a function a of t that represents the value of this investment t years after Alexander's birth. So, since this is not a compound interest problem, it's a continual growth, right? A of t is simply its principal, right? Multiplied by its percent, or in decimal form, so 0.012, right, to the t years. All right. So, in other words, okay. So t is equal to years, or years after Alexander is born, right? And you can see how this works. So, oh, this t is not good. So here's what happens. At t is equal to 1, right? Wait, why is there a dot here? When t is equal to 1, that means 1 year after he's born, right? So it does... Why is there... Sorry. So at t is equal to 1, meaning the first year, the 1 year after he's born, you get 1.2% of 5,000. Okay? So 0.02 times 5,000. Alright. You get $60. Okay? Let's see, actually. Alright, so let's work on 34. It says, on the day Alexander was born, his father invested $5,000 in an account with a 1.2 annual growth rate. Write a function a of t that represents the value of this investment t years after Alexander's birth. So we have a of t, right? A is a function of time, right? Or t time. T time is years, right? So it's years, right? So what we know about this question is that it's not compound, right? He's getting 1.2% of his initial investment or his principal. So after the first year, you get 1.2% of that, and then 1.2% again, etc. So let's just say this was 10%, right? What would it look like? It would be $5,000, 10% of it, right? Would be 500, right? And then 10% would be 500. So you get 5,500, right, for the first year. 6,000, second year 6,500, 7,000, 7,500, etc. Right? So, but realize that each time, right, it is 5,000, right? It's 5,000 plus whatever he grows, right? So you're gonna have 5,000, right, times 1 plus 0.012, 1.2% in decimal form is this, to the t power. So you have 5,000 times 1.012 to the t, which is equal to a of t. Okay. So the question asks, so we wrote the equation, right? So now it tells you to compare to the nearest dollar how much more the investment will be worth when Alexander turns 32 than when he turns 17. So t is equal to 32 versus t is equal to 17. So we have a of 32 minus a of 17, right? Which is equal to a, which is equal to, right, 5,000 to the 1.012 32, right, minus 5,000 to the, oh, we don't have much space here. Let me make a little bit more space. Hold on. So 0.012 to the 17. So this is what I'm doing. This is 32 years old, 17 years. So let's do exactly that. So let's do 1.012. Remember, you should have a calculator for this. Times 5,000, right? Minus 5,000, okay? 1 point, oh, minus 5,000. So let's see how we can enter this all at once. So 5,000 to 32. That's 5,000, right? Minus 5,000 times 1.012 to the 17. So it's $1,200. Okay, so the difference is $1,200. All right. Is there anything else? Okay. Okay, so let's check our math with a graphing calculator. So we have 5,000, 1.012 to the 32 minus 5,000 times 1.012 to the 17. Right, so we get the same answer as we did before. So to the nearest dollar, it's $1,200 more between 32 years old and 17 years old. All right. Let's see. Stefan collected data from a travel website. The data concluded a hotel's distance from Times Square, Manhattan, and the cost of a room for one weekend night in August. Table containing these data appears below. Write the linear regression equation for this data set. Alright, that you're gonna have to just use a calculator and just plug these values into, like, this would be list 1, this would be list 2, and I believe under math or stat you should be able to do should be able to do one variable stats, and it should give you different regression, whether you want linear, exponential, quadratic, etc., or polynomial. All right. So let's do number 36. Okay. All right. 36. All right. A snowstorm started at midnight. Okay. So 12 a.m. All right. For the first hour, it snowed at an average rate of 1/2 inch per hour. Okay, so 12 a.m. to 4 a.m., right? My slope is 1/2, right? The snow then started to fall at an average rate of 1 inch per hour for the next 6 hours. So 4 a.m. Okay, so 4 a.m. to 10 a.m., right? It is 1x, right? 1 inch per hour, inch/hour, right? And then it stops snowing for 3 hours, so 10 a.m. to 1 p.m. 0, right? Because it stopped. Then it started snowing again at an average rate of 1/2 inch per hour for the next 4 hours until the storm was over. Okay, so 1 p.m. to 5 p.m. is 1/2 inch per hour. Alright, so let's see. So for the first 4 hours, right, it's got a rate of half, right? So let's see, how can I plot this? Okay, let me move this stuff. Here you go. So at 0, elapsed hour at 0, obviously, right? So by 4 hours, right? How much has it snowed? It snowed 2 inches, right? Because it's 1/2 inch per hour for 4 hours. It's going to be 2, right? So at 4 hours, it's going to be 2, right? And then from 4 a.m. to 10 a.m., right, you have 1 inch per hour, right? So from 4 to 10, right, so 6 hours or 10 hours elapsed, right? Let's see, 4 and then 6 to 10, which is 10, right? So 6 hours, so it snowed 6 inches. 6 plus 2 is 8, so it's going to be somewhere around here. If I'm not mistaken, yep. 10, right? And then 10 a.m. to 1 p.m., right? This is a span of 3 hours. It's 0, right? But you have to understand, cumulative snowfall is still the same, right? So it's still gonna be 8 for, what is it, 3 hours? So 1, 2, 3 hours, right? And then from 1 p.m. to 5 p.m., it's 1/2 inch per hour, okay? So it goes halfway, okay? This is 4 hours, so 1 hour, 2 hours, 3 hours, 4 hours. So it looks something like this. So let's just plug in lines. Okay. Looks like this. Goes like this. Goes like this. So that's how the snow looks like. All right. So let's look back at the question. All right. So if we look at the graph, right? So starts at midnight. For the first 4 hours, it snowed an average rate of 1/2 inch per hour, right? So after 1 hour, it snowed 1 inch. After 2 hours, or after 4 hours, it snowed 2 inches, right? Then it started to fall an average rate of 1 inch per hour. So next 6 hours, right? So 1 hour later, 1 inch, 2 inch, 3 inch, 4 inch, 5 inch, 6 inch. So for the next 6 hours, it snowed 6 more inches, right? Accumulated, obviously, right? So that's why we have 8 inches now. Then it stops out for 3 hours, so it's stagnant here. That's why you have a horizontal. There's no slope, right? And then it started snowing again at an average rate of 1/2 inch per hour for the next 4 hours. So basically, it's 1 inch every 2 hours, right? So every 2 hours, 1 inch. Every 2 hours, 1 inch, and it keeps going on forever. So you can actually draw a line. Actually, does the storm end? Let's see. 1/2 inch per hour for the next 4 hours until the storm is over. So I guess you could say it ends there because it apparently ends. Determine the average rate of snowfall over the length of the storm. State the rate to the nearest hundredth of an inch per hour. Okay. So how much has it gone to? You got 10 inches of accumulated snowfall in a span of, what is it? 17 hours. So 10 divided by 17, which is around, let's see, there's hundreds per hour. So 10's hundreds, so it's 0.59 inch per hour. All right, so that's for that one. Okay, that's it. So 0.59 inch per hour. Okay, so that's for number 36. Let's do 37 now. Alyssa spent $35 to purchase 12 chickens. She bought 2 different types of chickens. Americana chickens cost $3.75 each, and Delaware chickens cost $2.50 each. Write a system of equations that can be used to determine the number of American chickens A and the number of Delaware chickens D she purchased. Determine algebraically how many of each type of chicken Alyssa purchased. Okay. So $35 to purchase 12 chickens, right? So basically, we have A plus D is equal to 12, right? Why is that? Because the amount of American chickens and number of Delaware chickens added together is 12 chickens, right? And then let's see. What else do we know? The American chickens are $3.75 each. So 3.75 times A, right? Plus 2.5 D, right? Is equal to 35, right? Because if A represents the number of American chickens and D represents the amount of Delaware chickens that Alyssa bought, right? So A times 3.75 each plus 2.50 times D, so this is D, should be equal to $35 because she spent $35, right? So this is for part A, or the first part. Determine algebraically how many of each type of chicken Alyssa purchased, right? So now we can solve for either or. We can say D is equal to 12 minus A, okay? I personally like to work with fractions. So A, I would actually change it into, so this you don't have to change, but 3.75 is 3 3/4 times A, plus 2.5 times d is equal to 35, right? Here you go. This goes up to here. Okay, hold on. Okay, that's perfect. This is 12/15 over 4 a plus 5 over 2d. Remember, d is 12 minus a, so I can write 12 minus a is equal to 35. Okay. Alrighty, let's move everything up a little bit more. Okay, remember this is d. Oh, this is terrible. Anyways, so 15a, let's distribute this. 12 and 2 makes 6, right? So 5 times 6 is 30. Minus 5a over 2 plus 15a over 4 is equal to 35. Common denominator is 4. So I got 15a plus 120, right? Minus 10a all over 4 is equal to 35. Simplify the top. I get 5a plus 120 multiplied by 4 to both sides, right? To get rid of the 4. 4 times 30 is 120. 4 times 5 is 20. So 120 plus 20 is 140, right? I subtract 120. I get 5a is equal to 20 divided by 5. A is equal to 4. So if a is equal to 4, that means d is equal to 8, right? 12 minus 4 is 8. So d is equal to 8, a is equal to 4. So let's erase all of this. Obviously, if it's going a little bit too fast, you can always pause and just look at what's going on. We can close this off. Alright. This could be good. Alright, so let's check our answer, right? If a is equal to 4, right? I have 3.75 times 4 plus 2.5 times 8 should equal to 35. Obviously, this is true, right? Because 4 plus 8 is equal to 12. This is good. So let's check using a calculator for time's sake. So 3.75 times 4, that's 15 plus 2.5 times 8, 35. All right, so 15 plus 2.5 times 8, this is 20. This is equal to $35. So we are correct. All right. No, that's not it. All right. So she bought 15 Americana chicken, right? Or sorry, 4 American chicken and 8 Delaware chicken. Okay. Let's see. Each American chicken lays 2 eggs per day, and each Delaware chicken lays 1 egg per day. Alyssa only sells eggs by the full dozen for $2.50. Determine how much money she expects to take. And at the end of the first week with her 12 chickens. Okay. Each American chicken lays 2 eggs per day, and each Delaware chicken lays 1 egg per day. Alyssa only sells eggs by the full dozen for $2.50. Okay. Determine how much money she expects to take in at the end of the first week with her 12 chickens. Okay. So, all right, let's see. Let's dive into this. So, what we know is that, oh, sorry, wrong one. So, We know that there's four Americana chickens, right? They lay 2 eggs per day, right? So in one day, this is 4 of them, they lay 8 eggs, right? 8 eggs per day from each of the chicken. 8 eggs times 7 is 56, right? This is for A, right? Americana chickens. Each Delaware chicken lays 1 egg per day, so there's 8 of them, so they lay 8 per day times 7, right? 8 times 7 is 56, right? So they also lay 56, right? So in total you have 112 eggs, right? Determine how, and then it says Alyssa only sells eggs by the full dozen for $2.50, right? So determine how much money she expects to take in at the end of the first week with her 12 chickens. So we need to first divide 112 by 12, right? For each dozen, right? Because she can only sell a full dozen of eggs, right? So let's see. 1 goes into 0, 0. This is going to be 9. Because 9 times 12 is 108. Okay. So in other words, she can only sell 9 full dozen eggs, right? So 9 times 250, right? Let's see what that is. 9 times 2.5. She expects to make $22.50. Okay, that's it for this problem. So one key takeaway from this problem is that in total there are 56 eggs. Or sorry, in total there's 112 eggs, right? Let's go over this again. So Americana chicken, they lay 2 eggs per day. So there's 4 chickens. Each of them lay 2, so 8 per day. 8 times 7, right? 8 times 7, 56, just like I showed you here, right? For the full week. Delaware lays 1 egg per day, right? So 8 of them, right? 8 times 7, also 56. So we have 112, right? Remember, they only sell by full dozen, so I have to divide by 12, which is what I did here. I get 9 minus 108, right? I get a remainder of 4. So the 4 eggs, she can't sell them, right? Because they're not a full dozen. So in total, she can only sell 9 cartons, which comes out to $22.50. Okay, that's it. What is this? Is this for graphing? Oh, okay. Anyways, all right, that's it. Thank you for watching. Bye bye.